Okay, so what we're trying to achieve down here, just to quickly recap, is we are going to derive this relationship over here. Okay, so while deriving, by looking at the first moment of area, we came up with two new rules that the datum is at the global centroid. The analysis will be carried out from y variable is at its maximum. Okay. So there are three rules already. There's two more coming up. Okay. So now we're going to derive the expression over there, and I will let A to be B times C, because if you look at the cross-sectional area, the width is B, the depth is 2C, so it's 2BC. So this expression over here, I will split it up. Okay, so 3VY C squared minus Y squared. Okay, so the 4BC cubed, okay, I'm going to split to 2BC, and the next one will be 2C squared. Okay. So now I can replace the 2BC, all right, I can replace the 2BC with A. So it becomes 3BY C squared minus Y squared divided by A, and then we have 2C squared. Okay, we have 2C squared. Okay, then we will have 3/2 by over A. I bring the C inside, C squared minus Y squared over C squared. So this expression will be equal to 3/2 Vy over A, and then is 1 minus by Y squared over by C squared. Okay. Now, what does this actually mean? Okay, you look at the equation, what does it actually mean? Okay, so I'm going to bring the diagram again. Okay, I'm going to paste down here. Excuse me. I'm going to make it smaller. Okay. So what does this actually mean? Okay, we look at the expression over there. So this multiplier over here, right, is going to be always less than 1. Okay, it's going to be always less than 1. Okay, or it can be less than equal to 1, always, right? And when y is equal to 0, right? When y is equal to 0, we will have our shear xy max, right? So it will be equal to 3/2 by over a, right? At y. So i.e. at the centroid is where y is going to be at maximum. Okay. So now I'm going to sketch the distribution now. So this is our y. And this is our shear xy. 0. Okay, so we have a point here. We have that a point here. Right. It will be hit its maximum. Okay, and then you get this shape over here. Why is it a set face? Why is it set face? Because the coefficient of the y squared, you have a what? A minus over here. Okay, so this value over here is 3/2 Vy over A, and this is your tau max. So your maximum shearing stress is located at the centroid. Okay, so tau max will occur at the centroid. Okay. Any questions so far?
Sorry, do you mind explaining that graph again? Like
Okay.
when y equals 0.
So when y is equal to 0, you have your maximum shearing stress. Because when you substitute into this equation over here, right? When y is equal to 0, this expression over here will be equal to what? 1. So that's why tau max is equal to 3/2 by over a. Okpara, is that okay? Because when you ask me to explain again, I'm like a tape recorder, you know. I put rewind and I just press play. Does that make sense to you or no?
Yes, it does. I was just copying. That's why I missed that.
Okay, so you I feel like when he say, can you explain again? I press rewind and I press play again. I feel so bad. Okay. At least I'm like this. Okay. When I did my undergrad, when I asked the prof the same thing, can you explain again? He did the same thing, but he went louder. Okay. Okay. Anyway. Okay. So I hope you're finished copying. Anyone still need time to copy, or you are good to go? Okay. I don't see anyone say stop. Okay. So the rule number 4 is, okay, rule number 4 is one that is not derived mathematically at all. It's purely the amount of questions I've done. Okay, so rule number 4. Okay, the first moment of area region or region cannot cross or intersect the centroid. Okay, and rule number 5. Okay, rule number 5 is the shear flow Q is in one direction only. Okay, so one direction only. It either can be coming down or it can be going up. Okay, you cannot have a structure that you have down and up. Okay, this solution that we just derived will absolutely fail. Okay, so what do I mean by the area of the first moment of area cannot cross the centroid? Okay, so now let's say now we have a area of interest. Okay, so now we have I'm going to deliberately. Okay. This is our cross section. Okay. So this is our Y, Z rotation in the X. Okay. And this is our DY. Okay. And then I'm going to draw in green. Okay, this is green. Over here, this is our centroid. Okay, that's our centroid. So now, for example, Okay, for example. If you want to find this point, okay, I'm going to use a different, this point. Okay, you find this point. The area that you have to consider, right, is this area over here. Okay, right? So if we look at, now I'm going to quickly write the 4 rules. Okay, so rule number 1, V and I, or not comma, V and I are constant. Right? Rule number 2 is that the datum is at centroid. So we need to find our centroid, because the centroid over here now, this is our datum. Okay. Then rule number 3 is analysis direction will start from Ymax. And rule number 4, which is just seen, first moment of area cannot intersect centroid. And rule number 5, Q is in one direction. Okay. Rule number 5 for this case is pretty straightforward. It's always one direction for now. Okay. Okay. Now, if you want to find the area at the dot down there, right? That is the area that we consider. Yes? You agree? Because the analysis will start from Ymax and the analysis will come. So this distance over here is your Ymax. Right? And then the analysis direction is going inside. Right? Now, what if now, okay, what if now I do the same thing? I paste. What if now Vy is here and the point of interest is still the same, the red dot. This is the point of interest. Okay. That's a point. Now, the question is, which area do you consider? Okay. Do you consider still the same? Do you still consider this area? Okay. Do you consider this area? Or I'm going to copy the same thing. Do you consider this area? So same point of interest. Okay. Excuse me. Or do you consider this area? if your V